All right, welcome everyone to another deep dive. And if you're a UPSC aspirant, this one is definitely for you.
We're going to be breaking down ISRO's recent 100th successful rocket launch.
It's a big deal, and we're going to help you make sense of it all for both mains and prelims.
And we're going to be drawing from the best sources out there, the Hindu, Indian Express, and of course the PIB reports.
So we've got a lot to unpack.
ISRO hitting that 100th launch really puts them in a whole different category.
Yeah, it's David versus Goliath out there, but with rockets and satellites.
Exactly. And what makes this 100th launch so special is this NVS-02 navigation satellite.
NVS-02. Tell me more about that and how it got up there.
Well, it went up on the GSLV F-15 rocket, but the important thing here is that it's the 8th time they've used a completely homegrown cryogenic engine.
Oh, wow. So they're really pushing that self-reliance angle.
Oh, absolutely. And you know how those cryogenic engine questions keep popping up in the UPSC exams?
Yeah, for sure.
This is why it's a big deal. ISRO is serious about not depending on other countries for this technology.
Okay, so that's NVS-02 and the cryogenic engine, but backing up for a second, what exactly is this satellite doing up there?
So this NVS-02 is actually a replacement satellite for NavIC.
NavIC, okay. So remind us what NavIC is all about.
It's India's own regional navigation system.
This is like our own GPS.
Exactly, and it's potentially even more accurate than GPS, especially within India.
Interesting. So what makes this NVS-02 different from the other NavIC satellites?
Well, there are a couple of really interesting upgrades. First off, it's got an indigenously developed atomic clock.
An atomic clock in space? Now, that's something I need to hear more about.
This clock is incredibly precise. We're talking about losing or gaining 1 second every 15 billion years.
15 billion years. Wow, that's some serious accuracy.
It's essential for a navigation system like this because the more accurate the clock, the better you can pinpoint locations on the ground.
I see. So it's not just about keeping time, it's about making sure those navigation signals are spot on.
Precisely. And for things like disaster management, even a few meters can make a huge difference.
All right, if you're trying to coordinate rescue efforts, you need to know exactly where people are.
Absolutely. So this level of precision is crucial.
Okay, I'm already seeing how this could be a great example for UPSC essays.
Self-reliance, technological advancements, implications for disaster management, it's all there.
Speaking of which, the reports also mention something about an L1 frequency.
Ah, yes, the L1 frequency.
What's so special about that?
Well, it's all about compatibility.
Compatibility with what?
With devices that use GPS.
Oh, I see. So by using the same frequency, ISRO is making sure that NavIC can work with a wider range of devices.
Exactly. It's about making their system accessible and easily integrated with existing technology.
Smart move, very strategic, but it's easy to get caught up in the specifics of this one launch when ISRO has this whole incredible journey behind them.
Absolutely. They've come a long way since 1969.
That's right. 1969, while the world was watching the moon landing, India was starting its own space program.
And in those early days, it was a lot of learning and taking small steps.
And now look at them, 100 rocket launches under their belt.
It's remarkable, really.
So tell me more about the evolution of their launch vehicles. It wasn't a straight shot to the top, was it?
Oh, definitely not. Over the years, they've developed different generations of launch vehicles.
Kind of like how cars have new and improved models each year.
Exactly. Each generation of launch vehicle is more powerful and capable than the one before it.
Okay, so walk me through, what are the different types of launch vehicles ISRO is working with now?
Right now, they have 4 main types in operation, each with its own specialty.
Okay, I'm all ears, lay it on me. What are these workhorses of the Indian space program?
Okay, so first up, you've got the PSLV. That's the Polar Satellite Launch Vehicle.
The PSLV, I've heard of that one.
It's the reliable workhorse. They've launched it over 60 times, and it's known for putting satellites into polar orbits.
Okay, so that's for polar orbits. What about the other types of orbits?
For that, you've got the GSLV, the Geosynchronous Satellite Launch Vehicle.
GSLV, right. Designed for those heavier satellites.
Exactly. It puts them into geostationary orbit, which is much higher up, about 36,000 kilometers above the Earth.
And that's where a lot of our communication satellites are, right?
You got it. And remember those cryogenic engines we were talking about?
The ones ISRO developed themselves.
Yeah. Well, the GSLV used to rely on Russian engines, but now it uses India's own indigenous cryogenic technology.
So the GSLV F-15 that launched NVS-02, that's part of this GSLV family.
Exactly.
Another win for Make in India.
Absolutely.
But wait, you said there are 4 main types of launch vehicles right now.
Right. We've got 2 more to cover.
Hit me with them.
So for the really heavy lifting, you've got the GSLV MKII, also known as the LVM-3.
The LVM-3.
Yeah.
Now, that's a powerful
It
beast.
is. It's currently India's most powerful rocket and has been
Hmm.
crucial for missions like Chandrayaan-2 and Chandrayaan-3.
And they're even adapting it for Gaganyaan, right?
That's right. India's first human spaceflight mission.
Okay, so we've got the PSLV, the GSLV, the LVM-3. What's the fourth
The
one?
fourth one is the SSLV, the Small Satellite Launch Vehicle.
SSLV. So that one's for the smaller, lighter satellites.
Exactly. They've really got all their bases covered.
It's amazing to think about all the satellites ISRO has launched over the years. Do you know the total number?
It's over 500 so far, both Indian and foreign satellites.
Wow, 500. That's incredible.
And it's not just about quantity. They've also been involved in some major scientific missions.
Oh, yeah. Definitely beyond just putting satellites into orbit, they've done some groundbreaking work.
Things like Chandrayaan, India's lunar exploration program, and Mangalyaan, the Mars orbiter mission.
Right. India made history with Mangalyaan becoming the first Asian nation to reach Mars.
And then you've got AstroSat, India's first dedicated multi-wavelength space observatory, and Aditya L1, the upcoming mission to study the sun.
Wow, they really are making their mark on space exploration.
Absolutely.
Okay, so we've covered ISRO's past and present, but what about the future?
Now that's where things get really exciting.
What's next for India's space ambitions?
Well, they have some pretty ambitious plans in the works.
Like what? Give me some hints.
Think sample return missions from the moon, a mission to Venus, even their own Indian space station.
An Indian space station. Wow, that's ambitious.
And of course, we can't forget about Gaganyaan, India's first human spaceflight mission.
So many possibilities.
Yeah.
So many potential essay topics for our UPSC friends out there.
Absolutely. But to pull off these ambitious missions, they're going to need something even more powerful than the LVM-3.
Okay, you've piqued my curiosity. What could be more powerful than the LVM-3?
That's where the NGLV comes in.
The NGLV, what's that all about?
The NGLV stands for Next Generation Launch Vehicle, and it's going to be a total game changer.
Okay, I'm hooked. Tell me more about this NGLV. What makes it so special?
Picture a rocket twice the size of the LVM-3,
Wow. Okay, that's big.
capable of carrying 30,000 kilograms to space.
30,000 kilograms. That's like carrying a whole apartment building up there.
Pretty much it's going to be a beast, and it's designed with reusability in mind.
Reusability, you mean like landing the rocket back on Earth?
Exactly like SpaceX does with their Falcon 9 rockets.
So they're going to land this giant rocket back on Earth.
That's the plan. It dramatically reduces the cost of space launches because you can use the same rocket multiple times.
Makes sense. Launching things into space is not exactly cheap.
Not at all. So reusability is a huge factor in making these ambitious missions more feasible.
Okay, so the NGLV, it's powerful, it's reusable, but at the end of the day, how does all this space stuff benefit the average person here in India?
That's a question a lot of people ask, and it's a good one because sometimes it's easy to get lost in the excitement of rockets and satellites.
Right, it all sounds cool, but how does it actually translate into real-world benefits?
We'll take NavIC, for example.
Okay, NavIC, our own homegrown navigation system.
We talked about how accurate it is, but that accuracy has some serious implications for things like disaster management.
Oh, I see. So in a crisis situation, knowing exactly where people are can be crucial.
Exactly. It can help with coordinating rescue efforts, getting aid to the right places quickly.
So it's not just about getting directions to the nearest restaurant.
No, it's about saving lives, potentially.
Okay, now that's an impact I can understand. And it's not just NavIC, right? ISRO's satellite technology plays a role in so many other fields.
Absolutely. Things like telecommunications, weather forecasting, agriculture, even urban planning.
Whoa. Okay, break it down for me. How do satellites help farmers, for instance?
Well, they have special sensors that can monitor crops from space, giving farmers valuable data on things like soil moisture, crop health, even potential pest infestations.
Wow. So they can literally see how the crops are doing from hundreds of kilometers above the Earth.
It's incredible, really, and this information helps farmers make better decisions about irrigation, fertilizer use, pest control.
So it's about optimizing the whole farming process.
Exactly, making it more efficient and ultimately leading to better yields.
So more food on the table thanks to space technology.
You got it. And it's not just agriculture. Satellites are also being used in urban planning.
How does that work?
They can capture high-resolution images of urban areas, providing data on things like land use, population density, traffic patterns.
Wow, so city planners can actually see how the city is growing and changing.
Exactly, and that information can be used to design better infrastructure managed traffic flow plan for more sustainable urban development.
It's amazing to think about all the ways Space technology touches our lives without us even realizing it.
It really is. It's about pushing the boundaries of scientific knowledge, but also about using that knowledge to address real-world challenges.
It's inspiring,
Hmm.
but let's face it, achieving these grand ambitions, like a space station or a human mission to the moon, it can't be easy.
No, it definitely comes with its own set of
Like
challenges.
what are some of the hurdles ISRO might face in the future?
Well, one of the biggest ones is funding.
Funding, of course. Space exploration is not cheap.
Not at all. We're talking cutting-edge technology, highly skilled personnel, complex infrastructure. It all adds up.
Right, and those big ambitious missions like a moon base or a Venus mission, those require a lot of resources.
Absolutely. And then there's the challenge of attracting and retaining top talent.
Talent, what do you mean?
The space industry is booming globally, with private companies like SpaceX and Blue Origin really shaking things up. ISRO needs to make sure they can compete for the best and brightest minds in science and engineering.
So it's like a brain drain situation, but in reverse.
Exactly. They need to create an environment where talented scientists and engineers want to stay in India and contribute to ISRO's mission.
Makes sense, and I imagine there are also some inherent technological challenges when it comes to space exploration itself.
Oh, definitely. Things like designing spacecraft that can withstand the harsh environment of space, developing new and more efficient propulsion systems, ensuring reliable communication over vast distances.
It's like a giant cosmic puzzle with incredibly high stakes.
That's a good way to put it. And it's not just about solving technical problems. There's also the whole aspect of international collaboration.
International collaboration,
Mhm.
why is that a challenge? I would think working with other space agencies would be beneficial.
It absolutely can be things like pooling resources, sharing expertise, reducing costs. Those are all major advantages.
So what's the catch?
The catch is that navigating the complexities of international partnerships, agreements, technology sharing it can be tricky.
I see, it's not just rocket science, it's international relations too.
Exactly. It requires diplomatic finesse, a clear understanding of the geopolitical landscape.
And with the rise of private space companies and the growing militarization of space, that landscape is becoming increasingly complex.
You got it. So ISRO needs to be strategic in its collaborations, ensuring they align with India's national interests and contribute to its long-term goals in space.
Okay, that makes sense. And there's one more challenge I want to touch upon, public perception.
Public perception, interesting. Why do you think that's a challenge for ISRO?
Well, because space exploration is a long-term investment, right? It requires sustained public interest and understanding to justify the allocation of resources.
Exactly, and to inspire future generations of scientists and engineers.
So it's not enough to just make scientific breakthroughs. They also need to communicate the value of those breakthroughs to the public.
Precisely, they need to make space exploration relatable, exciting, something that people feel invested in.
Because at the end of the day, ISRO's success depends on the support of the Indian people.
Absolutely, it's a national endeavor, a source of pride and inspiration.
It's a reminder that space exploration is not just about scientists and engineers. It's about all of us. It's about national pride, scientific progress, and pushing the boundaries of human knowledge.
And speaking of pushing boundaries, I have one final thought-provoking question for you and our listeners.
All right, hit me with it. What's the question that's going to leave everyone pondering even after this deep dive is over?
How might ISRO's advancements in space technology impact other sectors in India, and what challenges might they face in achieving their future goals?
Ooh, that's a good one. It really gets to the heart of why this deep dive is so relevant, especially for our UPSC aspirants. We've talked about the direct applications, navigation, communication, disaster management. But what about the ripple effects? How might these advancements in space technology spill over into other sectors, driving innovation and progress?
Think about it. The technologies developed for space exploration often find applications in other fields. Material science, for example. Developing lightweight, durable materials for spacecraft can lead to innovations in other industries like aviation or even construction.
Right, and the expertise gained in areas like data analysis, remote sensing, and robotics can be applied to fields like agriculture, healthcare, and environmental monitoring.
Exactly. It's about recognizing the potential for cross-sectoral innovation and fostering collaborations between ISRO and other industries.
So ISR's work has the potential to be a catalyst for progress across a wide range of sectors, not just space exploration. But on the flip side, what about those challenges in achieving their future goals? What are some of the hurdles they might face?
Well, we've touched upon some of them: funding, talent retention, technological complexities, navigating international collaborations. But there are other factors to consider as well. The global space landscape is evolving rapidly. The rise of private space companies the increasing militarization of space, the geopolitical implications of space exploration. These are all factors ISR will need to navigate carefully.
It's a whole new era of space exploration, and the stakes are higher than ever before.
Yeah.
It's not just about national pride anymore, it's about economic dominance, technological supremacy, and the very future of humanity's presence in space.
And that brings us back to the importance of public perception and support. For ISR to thrive in this evolving landscape, they need the backing of the Indian people.
It's a reminder that ISRO's journey is not just a scientific endeavor, it's a national endeavor, and it's one that we can all be proud of.
Absolutely. ISR's story is one of perseverance, ingenuity, and a relentless pursuit of scientific knowledge, and it's a story that's still being written.
Well said. And on that inspiring note, we've reached the end of our deep dive into ISRO's incredible journey. We hope you found this episode informative, engaging, and thought-provoking, especially for our UPSC aspirants out there. Remember, ISRO is a goldmine of potential essay topics, current affairs questions, and even science and technology-related queries for your prelims. So keep those notes handy.
And if you enjoyed this deep dive, do us a huge favor and like, subscribe, and share this episode with your fellow UPSC enthusiasts and anyone interested in the fascinating world of space exploration. Don't forget to check out the Hindu Indian Express and PIB for more in-depth coverage of ISRO's activities.
Until next time, keep looking up at the stars and keep exploring the wonders of the universe.